shows who else. So, all right. So what we're talking about today is, and Isaac, if you don't mind, just kind of, if I move over back and forth, you can kind of move the camera.
Oh.
As needed. What we're going to be talking about today are something called interfaces. Okay. I'm probably gonna sit down. Talk to me. Have y'all ever heard the word interface before? Isaac, you can sit down. I say just sit right next to it. Is it recording? Yep. Interface. Have you ever heard the word interface before?
It's like it's what you see. Like it's kind of the thing you interact with.
Mm-hmm.
You know, the front end of it.
Gotcha. Yep. And Isaac, I want you to have your computer. If we end up moving back and forth, that's what I was suggesting. There he is. Okay, so the interface is sort of like where your interaction with the computer itself. Okay, like for instance, we've got the screen interface. That's kind of my point of contact between the computer. We've got the mouse and the keyboard interface. Right? If you have an iPad or an iPhone, you've got a little digital keyboard that you can type on. So one of the things that we could talk about is, like let's say browsers. A browser gives you an interface to the internet. So talk to me something. What are some things that all browsers have to have if it's an internet browser?
Search bar.
Okay, it's got to have some sort of search bar or URL bar that you can type in. Okay. What else does it have to have or have to do?
Access to the material, the information.
Yeah, it has to have some way of actually connecting to the internet. You can't just have the bar there. It's got to have the back end part of it. Okay. Somebody else. What are some of the things that every single browser, whether it's Safari or Chrome or Microsoft Internet Explorer or Edge or whatever?
It has like the tabs up at the top.
Okay, that's pretty much a common thing. It's got to have.
Yeah.
Yep. I don't know. It doesn't have to have tabs, but that's pretty much a standard thing nowadays. Yeah.
Same with like a favorites menu.
Okay. Favorites, bookmarks. Those are sort of like things that we expect. There's sort of, if it's a browser, it's going to have something like that. I'm going to just even be a little bit more generic. It has to have some sort of window, right? That takes the information that it gets those ones and zeros, and turns them into pictures, text, video. Because when it's talking to the internet, it's getting everything back in binary code. Hey, Trey, if you don't mind, just put that away. I'm finished. Thanks. It's got to render it, is what we call it. It has to turn it into what you see there. That's what my browser is doing. It's turning the ones and zeros into colors, words. Even all of this stuff up here is all from the ones and zeros, the information that it's getting. Okay? So we could say these are different rules, these are different properties or methods or whatever that a browser has to have. So if something's a browser, it's got to do those things. Okay? So what we're talking about with Java is when they were making the Java language, they said, okay, we want to create this thing in Java which works kind of like this. And they said, what does that resemble? And the answer is an interface. Okay? So you'll also find out interfaces are kind of like the next step from inheritance, so parent and child classes, abstract classes, and now we're dealing with interfaces. Okay, so there was a progression along the lines here. So for instance, what was our animal of choice? Snake. Okay, so I don't know if we did this, but when we first talked about parents and children, or superclass and subclass, we could have had like a reptile class, and then from that, a snake class, which is a child of the reptile class. And so some of the different things that the reptile could do, it could move, and it could eat and whatnot. The snake could override that, right? So it could move, it could eat, it could, it had all of those properties, plus it had some others. It could, bite or attack and things like that. So that's why we use the word extends reptile. and that keyword extends was the connection between reptile and snake. Then, after just the basic parent-child relationship, we talked about abstract classes. Like vehicle, and we had vehicle was an abstract class with what we called abstract methods. So, for instance, the vehicle we could have like, I'll move again. But here, we actually would have like open bracket, close bracket. You remember that? Where it wasn't even defined. This was actually an abstract method right here. And we had concrete child classes, like the car class. And if you remember, if this class right here extends an abstract class, vehicle, then there were certain restrictions on it. An abstract parent was much more demanding than just a regular old parent. The abstract class says, I'm not going to give you any details on what this move thing is, but if you're going to be a child of mine, if you're going to extend this class, you darn well better give a definition for that move method. So you had to have move, and then you had to have, some lines of code inside of that. There was also the restriction that we could not instantiate an abstract class like we could with the concrete classes. Is this kind of making sense? Now, what we're going to talk about today is an interface, and it follows this progression of sort of like giving less information, but also sort of being more demanding from the parent. Okay? So since this is an interface, I might make some dashes rather than. So this is an interface. An interface has all abstract methods. It has no real method bodies whatsoever. Okay? So for instance, we'll say a pet obviously can move, but absolutely no code inside there. Also, maybe a pet can eat, but absolutely no code inside there. Unlike maybe some of these other vehicles, they had other methods, like a vehicle had like maybe is empty. You could have some lines of code inside there, even if it was an abstract class. And eat, you could have lines of code in there and move. But if you have an interface, then you have absolutely no lines of code inside your methods. An interface literally says, if you are a pet, then you have to eat and move, and you have to give descriptions of what that is and what that means if you're a child class. So for instance, we're going to look at a class called dog. And we're going to say that the dog class implements the pet interface. So we're going to use a different keyword here to relate our class to the interface. A couple of items about the interface. One is no method bodies. So effectively, all the methods here are abstract. Also, no instance variables. Technically, it's no non-static instance variables, but for our purpose right now, just say no instance variables. This one over here had a mixture. It had it could have had some abstract methods. This one over here had method bodies on all of them. But this is a new thing, and it's an interface. And so, what would an interface look like? Well, I'll show you. They're normally extremely small. Just a few lines of code. Here's one right here. public interface pet, open bracket, public abstract void eat. That's it. If I want to add another one, we have eat, I could say public abstract void move. That's it. And that would be self-contained within its own file. In fact, that's what we're going to do here in a second. But I'm going to get rid of that move one because it's not in the documentation. So then, so this is what that code would look like, public interface pet, or we could have had just void eat because the compiler understands that it's public and abstract. And then, if we look down here, we see public class dog implements pet. So that keyword implements is the new keyword for today, okay? And because dog implements that pet interface, it absolutely has to have brackets and some code in here to describe what happens. Well, I mean, you could have just comments or whatever, okay? So this may lead you to say, is it possible that I could have a class which implements an interface, but also has a parent class? And the answer is, yeah, you could. All right? So an interface is not a class. It looks like a class. It kind of resembles a class because I put a box around it, okay? And if you look at the code, look at that. It says public. Joseph, doesn't that kind of like resemble a class? Yeah, it does. But it's not a class. It's literally just a bunch. It's a list of methods. It's like saying, what is a browser? A browser has a title bar, has a way of a search bar, way of accessing the internet, a way of showing the data to the user, and a way of storing cookies, and a way of storing your favorites and your bookmarks. You know what I mean? All I'm listing is a set of requirements. I'm not telling you actually how it does it. Does that make sense? Mm-hmm. So that's what we would say. Chrome, the Chrome browser, implements a browser interface. Safari implements a browser interface. Okay? So, what we could have here, let's say there was another class that we had defined called security system. We'll say security sys. What's something that all security systems do? Sort of like if it's a security system, it has to protect. All right. It has a protect method, and maybe it has some sort of alert method, right? Well, we're writing our some sort of large program that involves security system and pets, and we realize that the properties of security system are all true of a dog, right? So it's possible that we could say that the dog inherits properties and methods from a security system. In which case we would say dog extends security system and it implements the pet interface. So you get all sorts of some new things going on here where a class can have a parent class and an interface. Now earlier I had told you that in Java we have only one parent families. Y'all remember that? Or one parent. You can only have single inheritance. You can only get from you can only have one superclass per a given class. However, Java does allow you to inherit from both an interface and, well, actually, it would say the proper term is inherit from a parent class and implement an interface. This is a little bit more. We're not going to do this in our code, but just so you know, it is totally possible. If we had an animal interface, okay, that dog could also implement the animal interface. So that's one of the neat things about Java is it allows you to implement multiple interfaces. However, you are limited with just single parent inheritance. Okay, let's go ahead and build this from the ground up. I think this would be kind of good for us. Let's go ahead and go to Eclipse, and let's create a new Java project. We'll call this interface demo. I'll put 6 for. So that I don't get it confused with the other stuff that I had. So interface demo 6. All right, and then we're branching out into new territory here. Let's go ahead and create a new interface. So when you right-click on your project and say new, don't go to class like normally. Let's go ahead and go to interface. And let's call it the pet interface. And there it is. In fact, if you look over here, you'll see that it's got a slightly different little icon. It's got a little eye right there. All right. What do we have? Public void eat. What else do we want every pet to do? Public void move, maybe?
Sleep.
Yeah, let's just speak. That sounds good. And I'm going to save it. That's it. That's the interface. It's literally just those 3 lines. Well, plus the 4th one, plus the little close bracket. All right? Saying, this is an interface. Anything that calls itself a pet must do these. How it does them, I don't care. But it would make the most sense if they did something sort of logical. Do y'all want to go with another snake, or do you want to go with dog? What do you want to do? What kind of pet do you want?
The dragon.
As much fun as it would be to do a snake again, you know, it's kind of almost like an inside joke that we have. I think we need to branch out. Let's do something else.
I love the dragon idea. Yeah, pet dragon. All right.
Yeah, we'll keep within like lizards for now.
Yeah, that's it. Yeah, real and
Reptiles.
logical. Okay. So let's make a new class, and we'll say dragon. We don't need a main method on this one. It does give you the option. Let's see.
Question.
Constructors from superclass, generate comments. Interfaces. We can add another interface, but I don't want you to do it here. Choose an interface. Ooh, that's cool. It's already there, but don't do it. That's cheating. All right. So, public class dragon. And then we'll do this by hand. It's much more fun if we do it by hand. Implements pet. And I'll save it. Is anybody getting an error?
It put package interface demo 6 on
Did you check any boxes? Okay. Package interface. That's really strange. Anybody else have an error?
Mm-hmm.
What's your error read?
The type dragon must implement the inherited abstract method pet.move.
Yeah. You guys should be getting an error saying, hey, wait a second. Mine says the type dragon must implement the inherited abstract method pet.eat. Right? So the thing is, Java's saying, hey, look, you said you were going to implement pet. And according to my recollection, pet has an eat and a speak. Did you just copy and paste it from the... Did you have move?
Yes.
Okay. I made mine have eat and speak. So I'm going to have to say public void eat. And I'm just going to leave it as a stub right there, and public void speak. And when I do that, because I have a method body, now those errors go away. Now it would probably be good if we added a little bit of code here, so I'll say system.out.println. The dragon is eating. And when he speaks, we'll say the dragon says, what does the dragon say? Does he roar? It's more like what a lion says.
Speaks in the dragon tongue.
There we go. Oh, that would not be school appropriate. Oh, so it can be like, doosh, wah, there you go. I got 2 3s in there. Give it some SHs and some CHs. It sounds like something the dragon would say. Alright. And I'll capitalize. Alright. Let's go ahead and create a client. So I'll say new class. We'll call this the dragon client. Or we'll create all our dragons. And we will create a main method here. So we can say dragon d1 equals new dragon. Dragon d2 equals new dragon. And we should say d1 dot eat and d2 dot speak. Have a little dinner conversation there. So just a couple of dragons hanging out. Watch us. Give you all a moment to get caught up on that while I take attendance. All right, show me that you've got that code up and running. Okay, looking good. Nice. All right, you with us?
Yeah.
All right, what else can we do here? Well, just like with our abstract methods and our abstract classes, it's also possible for us to create a variable, a pet variable, pet reference rather, so called P1, that can point to a dragon object. Okay? And that's what we're going to do next. So we can say pet P1 equals new dragon. We could say pet P2 equals new pet, and that's going to give us an error. Mason, what does that error say for you?
Cannot instantiate the type pet.
That's right. Since a pet is an interface, not only can you not have method bodies and instance variables, you cannot instantiate it.
Because it's an abstract.
Just the same as you could not with the abstract. Is that what you were asking? Yeah, it's very much like an abstract method. Okay, it's almost kind of like I'd say it's a parent class. It's a superclass. It's extremely demanding, but it doesn't give any real substance to the body. So it's kind of like a ghost parent. I don't know. You know, anyway, it's like a godfather. It makes all sorts of demands on you, but it's not really your dad. You know. Anyway, that's kind of the way that is. So also we cannot instantiate it. So that will not work. We can't say pet P2 equals new pet. So sorry P2, you're out. But since P1 is pointing to a dragon, we now can say P1 dot, and this is kind of a cool thing. Anything that a pet can do, we can do here. So you notice we have eat, we have all the standard methods that are inherited from object, but we also have the speak right there. Pet P1.speak. And just like we saw previously, because this is pointing to a dragon object, the version of speak that's going to get implemented, that's going to get executed, is the one from the dragon right here. So dragon, we have, let's see, what we have eat, and we had speak, and we had eat, and actual lines of code, and we had speak, actual lines of code. The thing about the interface is it's different from abstract classes and from just other regular parent classes, is that there's really not any confusion. Which one of these are we going to execute? Are we going to execute the reference, the parent, or the body here? And the answer is obvious. It's going to be from this particular class because there's nothing here. There's no code up there at all. Okay, before we move on to the next thing, are there any questions?
Can you do like a P1 equals D1?
Yes, great question. Could we do P1 equals D1? And what that just did in memory, so D1 was pointing to a dragon object, and now we've said, all right, P1 is now pointing to that same dragon object. Remember, great question. Now we didn't do this yet, but if we end up creating some variables inside of here, like if we give our dragon a name and property and an age and like a firepower, strength, and stuff like that, then obviously they're pointing to the same one. I'm okay right now not with doing the constructors. I feel like y'all are pretty solid on constructors and stuff like that, and instance variables. Other questions? Okay. That takes also care of a lot of the polymorphism stuff. There's actually two interfaces that the people who made the Java programming language have created. And let's go ahead and look at those. One of those was on the notes, the comparable interface. Okay? So we can look this up online. It's got a little bit more stuff here, but that's not really a concern to us right now. The comparable interface, though, is literally mostly just this. Public interface comparable, int compare to. And this interface is used a lot. Okay, lots and lots and lots and lots of different classes implement the comparable interface. And it's a pretty good interface to implement, because if your class implements this, then you are promising that you have a way of comparing your class, an instance of your class, with another instance of your class. And that happens, you need to do that a whole lot. When you're writing programs, you want to know, is this account the same as this account, or is this dragon the same as another dragon? Or even better, not only are they the same dragon, but which one comes first in the priority of dragons, okay? So the compare to method has 3 different types of return values. So it's an int, and if the 2 objects that are being compared are the same, it will return 0. If one of them comes before the other one, then it'll return -1. If one of them comes after the other, then it'll give a positive value. Okay? Let's go ahead and implement the comparable interface with our dragon. So this is pretty cool. Multiple implementations. So I'm going to say implements pet and comparable. Unfortunately, when I do that, it gives me an error. Obviously, it says, hey, you have to have, well, we've got to have the compare to property, or method. Int compare to object obj. I'm just going to grab that right there. Public int compare to. And then I'll give it a return type, and that's good enough for Java. It's really not doing anything right now. It's always going to return 0, so it's not really going to be able to compare things. Let's add a little bit of code here. We're going to give a property to our dragon. We're going to give it an instance variable. What are you going to say? Firepower? That's a way of comparing dragons, maybe, right? So private int, remember always instance variable is going to be private firepower. And we better, since we're going to have firepower, we need to have some sort of maybe constructor, public dragon int f, where we'll say firepower equals f. All right, so far so good. Very quickly, let's go back over to our Dragon client, and our constructors are now out of date because they had no values. I'm going to have one Dragon has a firepower of 5, and the other one has a firepower of 9. That should fix the problem. Oh, and pet p1 equals new Dragon, firepower of 42. Back to the Dragon. Alright, so the proper way to implement the compare to is to return 0 if they're both the same. And so the way that we're going to write this is we're going to say, the fundamental code is, we'll say like, this dragon dot compare to the other dragon. So if they're exactly the same, hold on, so we'll say this dragon is before the other, we're going to return -1. This dragon is equal to the other, return 0. And y'all just watch here, because otherwise if you type that, it'll take too long. So, but we will look at this tomorrow. So this dragon is after the other, return 1. Okay? So I'm going to have return 1, return -1, and return 0. So how are we going to figure out if those two dragons are the same? Well, we'll say if this dot firepower equals, other dot firepower, return 0. If this dot firepower is less than other dot firepower, return -1, and I'll just copy those two lines. Say if this dot firepower is greater than other dot firepower, return +1. So if you look up here, we did this kind of thing with strings. We look and say, let's compare this one with the other guy. If they're both the same, they give a 0. If this one is earlier, return a -1. If this one is after it, return a +1. Do y'all remember kind of talking about that with strings? I see those heads not moving, so that's great. Yeah, that's but if you look here, I've got an issue. It's saying other. It says, whoa, other cannot be resolved. Oh, that's because I need, it says OBJ. So let's write other up there. Okay. Now it says you've got the problem over here. Firepower cannot be resolved or is not a field. Now here's the problem. I'm acting like the other is a dragon, and I know it's a dragon. But as far as, because I'm only going to compare dragons, but as far as Java is concerned, and the compiler is concerned, other is of type object. Okay? So what I'm going to do is I'm going to take other and cast it as a dragon, so that then I have access to all of those items here. So I can say, dragon, other dragon equals casted as a dragon, other. And then I'll replace other with other dragon. And everything's nice and works out. This method must return, so notice I have to have something to return no matter what. I can go back here and I can do a system.out.println d1.compare to d2. Now what are we going to expect? 5, dragon 5 compared to 9 right here. Is it going to give us -1, 0, or +1?
Obi-Wan has taught you well.
1. 1? All right, let's find out. Come on now. -1, because D1 is 5 compared to 9. 5 is before 9, so it's going to give you a -1. If I change that 5 to a 10 or to a 15, come on now, can I run it? You look there, it's +1. All right, we'll talk about the list interface tomorrow and move on. Okay.